Let's take a look at some formulas and properties of summations now in sequences. So I printed these out for you, created a document for them. So I recommend that you print them out to have them available to you. You don't need to memorize these, just understand how to use them and it'll be fine. And again, I don't expect that you will need to memorize these. All right, so the properties are pretty straightforward. So notice property number one is telling us that if we had a sequence, C is just a real number. Notice C is a real number. Hey, there it is. Okay. And A sub n and B sub n are two sequences. Some of the properties have two sequences involved and show you what to do when you have that. So this is just a real number times our sequence function. So, we would be multiplying that real number times each term of the sequence. So we could greatest common factor that out to the front. So this is the same as C times the summation. So sometimes that makes it easier because that real number, we don't need to multiply it by each term. We can just find the whole sum and then multiply it by that number. Okay, so that's the first property. The second property says if we have sequence that actually has like one sequence and another sequence added, then you can separate those into two summations. So that will be easier. And I hope you think, these properties are pretty straightforward. Like they do make sense. You're just adding two different parts. So you can just take the sum separately and then add them together. Okay, same with subtracting. So, if you have one sequence minus another, the summation of those, it's the same as summing the one sequence and then summing the other and subtracting them. So in other words, the order doesn't matter. This last property, I'm going to try not to give you too many problems with it. You'll definitely use that in calculus. You'll do a lot of summation in calculus, and you'll definitely be using properties like this and more. And they're not too hard. It's just that this is like an introduction to summation notation in sequences. So I'm going to try to avoid giving you any of these. So we're not going to talk about that one right now. Next, some formulas. And again, you don't need to memorize these. You just really do need to understand how to use them. So this is the sum. Remember, C is a real number. So this is just the sum from k equals 1 to n of some number. Okay. What that means is you're going to add that number how many times? Oh, n times. Okay. So since it's just a repeated number added together, it's the number times the number of times it's added, right? So C times n. Second formula to find the sum, k equals 1 to n of k. So this is the index. So now we're not just adding the same number, we're adding 1, 2, 3, 4, etc. all the way to n. And the formula for that is n times n plus 1 over 2. Okay, so whatever n is. So if we actually know what the number that n is, we can plug this formula in and quickly find the sum. So like, let's say if n was equal to 100, I certainly wouldn't want to add 1 plus 2 plus 3 plus 4 plus 5, in my calculator all the way to 100. What a pain, right? So instead, I can use this little formula. Third, the summation of the index squared, so k squared. So in other words, we've seen this sequence before, 1 squared plus 2 squared plus 3 squared, all the way to n squared. And then that follows this formula right here. So n times n plus 1 times 2n plus 1 all over 6. Okay, and then finally k cubed. Now there could be a lot of other formulas for different sequences, but these are just the ones that we're going to study and use. So if you have k cubed, you know that what that means is the sequence is 1 cubed plus 2 cubed plus 3 cubed, etc. And then this is the formula that we'll use to find the sum. Okay, so using all these properties, let's do a couple examples to show how to use the properties and the formulas. So again, if you print that page out with the sequences, I think it will be helpful because then you can refer to them. Okay, so first problem, let's say, is let's find the sum from k equals 1 to 5 of 3k. Okay, 3k. So we can use the property first to say, well, the 3, that's that c, that's that real number, and that would be the same as 3 times the sum of k equals 1 to 5 of k, right? And so now we know whatever sum this is, we're just going to multiply it by 3 at the end. Okay, so let's do that. So the sum of from k equals 1 to 5 of k is this second formula. They call it number 6, right? Because we're counting up. In other words, this is 1 plus 2 plus 3 plus 4 plus 5. I mean, of course, it's only 5 numbers. We could actually just add them together. And maybe we'll do that to check it, okay? But in any case, we can use this formula, n times n plus 1 over 2. So that's 5 times 5 plus 1 divided by 2, okay? So that's 5 times 6 over 2. So 30 over 2, 15. Okay, now I actually should, since I have the 3 out here, I should really keep this 3. I don't like how I wrote that without the 3. So I'm going to fix that because you don't want to write things that aren't equal to each other really. So this is 3 times all this stuff, and this is 3 times the 15. So, the k summation is right here, 15, and then 3 times 15. So our total is 45. Okay, now if you wanted to not use the formula to find this part, this would be just 1 plus 2 plus 3 plus 4 plus 5. So that looks like 3 plus 3, 6 plus 4, 10 plus 5, 15. Okay, that's just the formula worked out. All right, let's do another. B is going to be the sum of k equals 1 to 10 of k cubed plus 1, okay? So this is using one of the other properties where we want to separate it out into 2 summations. So we want to do one summation of k to from 1 to 10 of k cubed, right? Because we have a formula for that. And we're going to add that to the summation of k equals 1 to 10 of 1. We actually have a formula for that as well, right? So it's going to be much easier to do these 2 things separately, and we're going to use the formulas. So for the first piece, our k cubed formula is right here, n times n plus 1 over 2, all squared. So let's plug that in. Notice that n here is 10. So that is 10 times 10 plus 1 over 2, all squared, okay? And then this other summation is just the number 1, and that is the first formula here, formula number 5. So because c is a real number, that number is 1. So we just want to do c times n. So this is 1 times 10, okay? Now let's see if I can work this out without having to use extra paper. So 10 times 10 plus 1 over 2. So that's 11 times 5. So that's 55 squared, I think. 55 squared. Does that seem right? Let's see. 11 times 5. Yeah, okay. And then this is plus 1 times 10. So plus 10. Okay. So we're getting 3,025 is the 55 squared, use a calculator, plus 10, so that's 3,035.